Welcome to solverfy.
.24. So we have 2 point sources that are emitting light of the same wavelength and are in phase with each other. And so there are 2 wavelengths, there are 6 wavelengths apart, and the screen is 20 wavelengths away. First, we want to know the value of xp here. This is a point that's just under consideration. It can be anywhere along the screen where there's a minimum phase difference. Now, every point except for right here at xp equals 0, there's a difference in the path lengths between the 2 sources. Whereas here, right in between them, the path lengths are the same, and so that's where their minimum phase difference is going to be. And that phase difference is going to be 0 also. Now part C is where do they have the maximum possible phase difference. And so you can see that as we move further and further along the screen, the difference in path lengths is going to increase. And that's going to increase all the way up to infinity. At which point, we have our 2 point sources that recall are 6 lambda apart. And infinitely far away, the rays will basically be going horizontally like this. Pretend that's overlapping that directly. And so the path length difference is going to be this 6 lambda. Also, this should be a D and not a B. Sorry about that. D. E we want to know what the phase difference is in multiples of lambda when we're 6 lambda along the screen here. So, say pretend this is 6 lambda. I guess actually it would be equal to the distance between these two, and so you would be somewhere over here, but whatever. And so the phase difference in units of lambda is going to be 1 over lambda times the difference in path lengths, which we just find using the Pythagorean theorem. We have 2 distances we know, the distance to the screen and the distance along the screen, and so we can figure out the length of the hypotenuse of that. So this is d squared plus x plus d squared for this one, because we'll have x plus d as our distance horizontally. Minus the square root of big D squared plus x minus d squared. And this is that's this, because you go x minus d to get back to where the point actually is. So putting in 20 lambda here, 6 lambda here, and 6 lambda here, and then similarly over here, we get a phase difference of 1.71 wavelengths. Now for part F, we want to know whether this is a minimum, a maximum, or somewhere intermediate in terms of intensity. So 3/2 would be a minimum, 2 would be a maximum. So this 0.6 lambda along the x direction is intermediate, and it's slightly closer to a minimum than it is to a maximum.